Okay, question 1 of the test. We've got f of x is 6x cubed minus 5x. So part A, f dashed x is going to be 18x squared minus 5. And part B, f double dashed x, so you're going to get 36x, but it's f double dash of 2. So obviously 36 times 2, which is 72. Now, of course, that second one could have been checked and done on your calculator. So question 2, you've got the coordinates 3, 0 and B, 9, 8. Now, AB, that's a diameter of a circle. So you could do a little sketch if you wanted to. 3, 0 is A, 9, 8. So you're going to be way up there. So you're going to have some kind of circle thing going on there, A and B. And that's your diameter. So it's a bit of a poor sketch there. Right, it tells you, or it asks you to find the coordinates of the centre of the circle. So the first thing you want to do is find the midpoint. Now remember, when you find the midpoint, you find the mean average of the of the x values and the y values. So make sure you're adding them if you're using this method, not taking them away. Or just think, what's halfway between 3 and 9? What's halfway between 0 and 8? So there was a method mark for doing this. So there was a method mark. So obviously you're going to get 6, 4 as your midpoint. So there's your midpoint, your centre, 6, 4. And then it says, find the equation of the tangent to the circle at the point B. So if you think about, so part B, I'll draw another sketch here. So here's your circle, and here's point B. So you can see that the equation of the tangent is perpendicular to the radius. So the first thing you have to do is find the gradient of the radius. And you're using your coordinates you're using your centre 6, 4 and 9, 8. But you don't have to. You could have used A and B because the gradient of the radius is the same as the gradient of the diameter. So I'm going to use y2 minus y1 over x2 minus x1. I'm going to call this point 2 and this point 1. So the gradient of my radius is 8 minus 4 over 9 minus 6. So it's 4/3. Now if the gradient of my radius is 4/3, the gradient of the tangent, okay, and this is only because it's a circle, so the gradient of the tangent is at right angles, so I take the negative reciprocal. So make sure you're taking the negative reciprocal there. And now you want to find the equation of the line with a gradient -3/4 going through point B. And point B is the point 9, 8. So what I'm going to now do is I'm going to use my y2 minus y1 equals m x2 minus x1. And I'm going to substitute my values in. So I've got a gradient of -3/4 and I've got my point, which is 9, 8. So I'm going to have y minus 8 equals -3/4 x minus 9. And then I'm going to multiply all through by 4. So it will give me 4y minus 8 is -3x minus 9, expand those brackets. And then it's up to you how you're going to do this. It hasn't specified how it wants it, so it's not that bothered. So if I bring that 3x over here, I'm going to have 3x plus 4y. And if I add 32 to both sides, I'm going to get 59. So there we have the equation of the line, but you might have given it in another format. So we're looking for the numbers 3, 4, and 59 in the answer. Let's now look at question 3. Now, question 3, it's not particularly difficult, but because it's a proof, they're very specific in what they want to see. So you've got to make sure that you've done certain things that they are going to require. Now, you're given this formula, so you're straight away, you should be thinking about what f of x plus h looks like, and you then subtract from it f of x. So if you think about what that's going to look like, so straight away, using my formula, I know that f dashed x is f of x plus h minus f of x all over h. And what I should have written in there, if you've got on your formula, I should have written the limit as h tends to 0. So I'm going to be better this time. F dashed x, limit as h tends to 0. Now my function, x squared, so I'm going to have x plus h all squared minus 4x plus h. And I'm now going to subtract from that f of x, which is x squared minus 4x. So people that lost marks here, it was because they hadn't put the bracket in. So really important. So that's all over h. So we're now going to have, so if I expand my x squared plus h, so I'm going to have x squared plus 2xh plus h squared minus 4x minus 4h minus x squared plus 4x. So make sure that you've got that expanded properly, because you know what can happen is if you do like a double mistake, you end up with the right answer, which obviously isn't going to be okay. Also, be careful showing cancelling, because they do want to see. If you just have lines to everything, the examiner's not going to be able to see what it was that you found. So yes, the minus 4x and the plus 4x, and maybe I should have gone with my x squareds there. So obviously that is going to cancel. My x squareds are going to cancel. So I've got minus 4h minus x squared. So I've cancelled my 4x's very slightly. I've probably put in an extra line there that I could have done without. So the limit as h tends to 0. I've got 2xh plus h squared minus 4h all over h. Again, it wants to see that. So if we keep going, so we've got my limit as h tends to 0, just checking that you can still see my answers. So I'm now going to show this cancelling. Remember, it's a proof. Don't cut any corners because you know what the answer is. So limit as h tends to 0, I've got 2x plus h minus 4. Now the mark scheme wants to see that. So your answer, f dashed x, as h tends to 0, you can see you're going to get your 2x minus 4. So make sure that you don't cover up or you're working with your cancelling. Right, next question. So we have indefinite integration, and that means no limits, and make sure that you are putting your plus c. So a mark was taken off. So the first one should be quite straightforward for you. So you raise the power, divide by the new power. So you're then going to have minus 3x squared plus c. Part B, what we're now going to do for part B is you're going to rewrite it first. So your integral, so remember 4x squared, 4 over x squared is 4x to the minus 2. And now raise your power by 1, which obviously when you add 1 to negative 2 becomes negative 1. And then you will divide that 4 by your new power, minus x plus c. And some of you were very good and put it back like that, but obviously that's fine as well. Right, question 5. So coordinate geometry. So find an equation of the normal to this curve. So the first thing I'm going to do is I'm going to rewrite my curve in index form. Now, your calculator will do this for you. It will find the dy dx at x equals 4. But really, we ought to be getting ready for detailed reasoning. So the first thing I'm going to do is I'm going to differentiate this. So my 2 is going to multiply with my half and make it 1. So x to the minus a half plus 4x to the minus 2. So there's my dy dx. Now, I think I might prefer to write that as 1. I'm going to write it like this, but you don't have to. Okay, there's dy dx. And I would like to find that when x equals 4. Again, you've got your calculator, you could put it into 1 over the square root of 4 plus 4 over 4 squared. So I think dy dx is half plus 4 over 16. So if I put that into my calculator, I know it's 3/4. So I know that that is the gradient of the tangent. That's the gradient of the tangent. It doesn't want the gradient of the tangent, it wants the gradient of the normal. So I'm going to take the negative reciprocal of that. So the gradient of my normal, just checking the stone shot, will be minus 4 over 3. Now we need to get an equation of a line, we will need a point. Now we know that when x equals 4, we can find y. Y is 2 root x minus 4 over x. So y will be 2 times the square root of 4 minus 4 over 4. Y will be 2 times 2, take away 1, y will be 3. So there's our point that lies on the line. So we've got gradient of minus 4/3 and the point 4,3. And again, it's using this skill. But the difference is this time they told you how they want the answer given. So y minus 3 is minus 4/3 x minus 4. I'm going to multiply both sides by 3. And now I'm going to expand my brackets. So add 4x to both sides and add 9 to both sides. Right, question 6. So question 6, I've got 7 marks, so there's quite a lot going on in question 6. So there was a key issue in question 6 where people made mistakes. So 6 part I, find the stationary points. Now stationary points literally mean dy dx equals 0. So that's where our curve will have a gradient of 0. It's where the curve turns. So first of all, I've got y is 2x to the 4 minus x squared. So dy dx is 8x cubed minus 2x. Now this will equal 0 when 8x cubed minus 2x equals 0. Okay, you can divide through by anything that cannot be 0. So I can divide all through by 2. I cannot divide by x, as tempting as it is, because the problem with dividing through by x here is I lose a solution. So it's really tempting to write that as 4x cubed equals x divided by x. That'd be so neat. But you can't divide by x because x equals 0 is the solution. You can take out a factor of x. So x is equal to 0, or 4x squared minus 1 equals 0, which means 4x squared is 1, x squared is a quarter, which implies x is plus or minus the square root of a quarter, which is a half. Now, it only wanted the x values. It did not ask for the coordinates. So it just asked for the x values. So that is enough for my first part. Determine in each case whether the stationary point, again, it's not asking me for the coordinate, it just wants to know whether these stationary points are maximums or minimums. So second derivative, so I'm going to differentiate again, so go back to my original, so I'm going to get 24x squared minus 2. When x is 0, that second derivative is going to be 0 minus 2. Negative, therefore maximum. Negative, sad face. X is a half. That means my second derivative. Now I know a half squared will be a quarter. 24 times a quarter is 6. 6 take away 2 is 4. Positive, therefore minimum. Positive. And if x equals minus a half, well, as soon as you square that, you're going to get exactly the same again. So less than 0. Okay, therefore minimum. And part 3. So hence state the set of values of x for which the curve is a decreasing function. So it's a decreasing function when the gradient is negative. Now you can tell whether a gradient is increasing or decreasing by looking at this, what's going on between the stationary points. So if you think what's happening, and of course you can put this into your graphical thing on your graph in your calculator, you know that you've got whatever is actually happening with the curve. In fact, I might not even draw the coordinate axes. Let's think about our x values. You've got 0, you've got a half, and you've got minus a half. Now you know that at 0 you've got a maximum, and at a half you've got a minimum, and at minus a half you've got a minimum. So obviously your curve doesn't look like that, but it's a really good way to summarize your gradient. So you can see that you've got a negative gradient here. So when x lies between a half and 0, and you've got a negative gradient here, where x is less than minus a half. Now, I'm just going to get my tea, and then I'm going to come back and do the log question.